One way to study the kind of relationship between concepts in physiology is to use a process called mind maps. It's also called concept mapping. But you basically start out with a central idea. So in this case, we're going to be looking at protein structure. And then from this basic starting point, you can kind of fill in the details that you know about it. And so in this case, protein structure can be corresponded to, there's a primary structure. There is going to be a secondary structure. There is going to be a tertiary or third level of structure. And finally, we've got a quaternary or kind of a fourth level of structure associated with proteins. And so once we've got that, so we've got protein structure, and we know that within that we've got primary, secondary, tertiary, and quaternary, and then we can go and start to fill in some details. And so the primary structure, if we start to fill in the details over here, we know that it's going to be coded, actually I should probably start at the beginning. The primary structure is going to be the sequence of amino acids. So kind of in a chain of amino acids forming the polypeptide, which forms this protein. And so we're going to get amino acid 1, amino acid 2, amino acid 3. From this, you can again branch out and say it's going to be coded by messenger RNA. If you want to go deeper, you can talk about the fact that the messenger RNA is coming from DNA transcription. Go even deeper, the relationship of exons and introns. Also, we can think about mutations. And what we're going to have with a mutation, poorly spelled over here, mutations, we're going to have a change in the amino acid in a location. And because of that change in the amino acid, we're going to have an incorrect R group, that side group associated with kind of the function of that amino acid. And that could disrupt the shape of the protein, and it may result in a non-functional protein. And so the concepts for primary structure, sequence of amino acid, coded messenger RNA and how that messenger RNA is formed, what happens if we change that sequence of amino acids with the mutation, potentially disrupting the function. If we take a look at secondary protein structure, what we're going to see is basically we're looking at the relationship of hydrogen bonds, and these are going to be hydrogen bonds between the carbonyl group of one amino acid and the amino group of another amino acid. If we take a look at this, basically the negative charge of the carbonyl group, so we can indicate that it's negative over here, is going to be attracted to the positive charge of the amino group. Within the secondary structures, we can have an alpha helix. This alpha helix is basically going to be the polypeptide chain kind of going into a coil. And so we're going to look at the fact that the hydrogen bonds between the carbonyl group and the amino group are basically forming these weak hydrogen bonds, but many of these are going to form within the protein, like in collagen. And so what we end up with is a twisted protein. We may also see something like a beta-pleated sheet. In this case, instead of a coil like we have up here with an alpha helix, we've got the amino acid, the polypeptide kind of going back and forth, and we're forming hydrogen bonds kind of between structures like this, giving us kind of a flatter structure associated with this. If we take a look at the tertiary structure, again, the definition of that is going to be interactions between the R groups. So the R group, the kind of distinct portion of those amino acids, Examples of that could be like disulfide bridges. With the disulfide bridges, you're basically looking at cysteine amino acids forming a disulfide bridge, basically forming a chemical bond at that point. We could also look at interactions that are going to be attracted between positive side groups, so positive R groups, attracted to negatively charged R groups. And in addition to that, we could also have hydrogen bonds forming between, again, these R groups of these amino acids. And then finally, we take a look at quaternary structure. This is more than one. Sorry, that didn't come out real well. So you're looking at more than one polypeptide chain coming together, interacting to give us our functional protein. And so, if we're looking at something like these alpha helix up here, we could have a collagen molecule, which is actually three of these things kind of, and this is drawn really poorly, I apologize for that. Three of these amino acids kind of coiled together, giving us that triple helix that's going to be located almost like a braided rope within collagen. Another example of that, if we take a look at hemoglobin. With hemoglobin, we're going to have two kind of globular proteins. They're going to be interacting with two other kind of globular or type proteins over here. And we're also going to have heme groups. They're going to be present. And these heme groups are going to contain iron. And so basically a functional hemoglobin molecule is going to have four of these polypeptide chains coming together with these four heme groups, and the heme groups are going to be an organic ring with an iron atom attached to it, which allows for the transport of oxygen. So what we can see with this mind map is you can start out with a central process, kind of expand out with what you know, primary structure, sequence of amino acid, and then facts associated with the amino acid. To use this as a studying technique, you can draw it out as a way of studying it, or you can use it to test yourself and just say, okay, write down protein structure without looking at your notes. Basically fill in the equivalent of this mind map, and then going back and comparing it to your notes and saying, okay, I know most of this stuff, but I'm a little confused about what's going over here with these tertiary structures, these interactions with the R groups, and I need to study that a little bit more. Since my initial mind map, when I drew it out, was a little bit messy, I want to show you an application, or in this case, a program that I'm using on my PC, which I can also get an app to use on my iPad. This one is called Simple Mind. And so we can go through and create a mind map, create a new one here. And so I'm going to do demo. Didn't type demo correctly, but it's the same basic idea. You can type in protein structure here. And then within this, if you go, you got little pluses, and so we could do primary structure. Go back here, we want to add another one for secondary structure. Go back, add a third for tertiary structure. And then add a last one down here with quaternary structure. We can reorganize these by basically grabbing them, moving them around. And then, like we talked about before, for primary structure, we may say that we want to take a look at this as being the sequence type, sequence of amino acids. And then from this sequence of amino acids, we may take a look at coded by messenger RNA. Don't have the ability to move over there. Okay. Then grab it and move it over. And we also wanted to talk about mutations. And so you can basically going to go through and fill in all of the details, much like we did on the board on that previous slide. The nice thing about this is if it starts to get too complicated, we can go up here and click on that icon and basically collapse or expand what it is that we're looking at. I think there is some value to drawing it out on your own, but if you have messy penmanship like me, there may be an advantage to using some type of app. And there are a variety of them out there. This just happens to be the one that I use. So hopefully you can see how this is a possible way of studying different concepts and how these concepts are related in physiology.